Two planets in the same orbit. Our solar system is quite an orderly place. Each planet has its own orbit and orbits a star on it. This is also the case in most of the planetary systems we have discovered so far. However, a young system about 370 light-years from Earth is different. Research suggests that there are two planets in one of the orbits. If the observations are confirmed, it will be the first evidence of the existence of the so-called Trojan planets. Astronomers have found the first potential evidence of Trojan planets, two twin worlds sharing the same, or very similar, orbit around the same star. A similar example can also be found in the Solar System. These are Trojan asteroids, two groups of space rocks orbiting the Sun in an orbit occupied by Jupiter. The Trojan planet candidates orbit the young star PDS-70, about 370 light-years from our solar system. We know that there are at least two planets in this system, PDS-70b and PDS-70c. They are gas giants like Jupiter. But in the orbit of PDS-70b, astronomers observed something else. It's a planet. A large cloud of debris that could indicate a planet in formation or the remnants of an already formed but destroyed planet. The results and a description of the observations have been published in the journal Astronomy and Astrophysics 2 decades ago. It was theoretically predicted that pairs of planets of similar mass could be in the same orbit around their star. This so-called Trojan planets or co-orbital planets. Now, for the first time, we have found evidence supporting this concept, said Olga Balsalobre-Ruza, a student at the Center for Astrobiology in Madrid and lead author of the paper. The PDS-70 system is well known to astronomers. It was there that planets in the process of formation were first spotted. Here, too, astronomers observed a moon forming around PDS-70c. But a closer look revealed the existence of something else. In the images, scientists saw a faint spot, fainter than the exoplanet's signature, but in the same orbit as PDS-70b. Calculations suggest that whatever it is, it has about twice the mass of Earth's moon. The mysterious object is located near the libration point. These areas are also called Lagrange points. Every system of two bodies has 5 such points. These are places in space where the gravitational interaction between two bodies balances out. This makes these regions stable points in space where matter can become trapped. In the Solar System, the Trojan asteroids, Trojans and Greeks, are located at Jupiter's L4 and L5 points. One group is ahead of the gas giant, the other is close behind. Earth also has such rocks in its orbit. These points are also good places to park the observatories. The James Webb Space Telescope orbits the L2 point, about 1.5 million kilometers from Earth. Our research is the first step in finding co-orbital planets at a very early stage of their formation, said co-author Nuria Huelamo from the Center for Astrobiology. This raises new questions about Trojan formation, evolution and frequency in different planetary systems, added Itzia de Gregorio Monsalvo, head of ESO's science office in Chile, who was also involved in the study. But scientists have yet to confirm their observations. They now believe that PDS-70b's orbital partner is likely a dense dust cloud, the building block of a new planet, rather than an entire planet. You'll have to wait a while to check it out. In a few years, it will be possible to see if a potential planet or dust cloud is moving with PDS-70b as its co-rotating companion at L5. It would be a breakthrough in exoplanet research, Balsalobre Ruza said. The cuttlefish passed a test designed to test children's cognitive abilities. New research has revealed there's more going on in the strange brains of cuttlefish than we thought. It turns out that these animals are willing to give up the meal they have on hand when they know that waiting means a much tastier reward. This ability to delay gratification demonstrates cognitive abilities, such as planning, that are unlikely to be expected in a cephalopod. According to scientists, the ability to learn and adapt evolved in cuttlefish in the depths of the marine world to give the animals an advantage over predators. The team's research was published in Proceedings of the Royal Society B. The ability to delay gratification demonstrates cognitive skills such as planning for the future. The test that the cuttlefish was subjected to, commonly known as the marshmallow test, was developed to study how the human mind develops and at what age a person is smart enough to delay gratification when he or she may later get a greater benefit. A test conducted in the 1960s by Professor Walter Mischel of Stanford University consists in presenting children with a proposal. Either they eat something delicious now. In the original test it was sweet marshmallow, but it could also be chocolate or a cookie, and in the case of cuttlefish, shrimp. Or wait a while and then they will get more treats. Because the test is very simple, it was possible to adapt it to animals. Of course, there is no way to tell an animal that it will receive a reward if it waits. However, they can be trained to understand that they will get better food if they don't eat what's in front of them right away. Some primates, dogs and ravens have undergone a similar test. Cuttlefish, Sepia officinalis, was studied last year. It turned out that animals can refrain from eating a morning meal of crab meat when they discover that for dinner they will eat something they like much more: shrimp. A team led by Alexander Schnell from the University of Cambridge found that animals have the capacity for self-control and learning. Further studies were designed to confirm the results. The cuttlefish were placed in a special tank with 2 chambers containing snacks. One contains a piece of raw shrimp, and the other contains live shrimp, which cuttlefish like much more. There were also symbols on the doors of the chambers that the cuttlefish had learned to recognize. The circle meant the door would open immediately. The triangle meant it would open after a certain amount of time, and the square meant it would stay locked. During the tests, the dead shrimp was placed in a chamber behind an open door, while the door behind which the live shrimp was located was only opened after a certain period of time. If the cuttlefish reached for a dead shrimp, the live treat was immediately removed. The researchers found that all of the cuttlefish in the study chose to wait for the preferred food, live shrimp. The cuttlefish were able to wait for a better reward, which is comparable to that of vertebrates with much larger brains, says Schnell. The second part of the experiment was designed to see how well the cuttlefish could learn. The animals were shown 2 squares of different colors. Choosing the right one meant being rewarded with food. It turns out that cuttlefish have learned to adapt to the situation. Researchers do not know how similar abilities in animals living deep in the ocean come from. It's possible that the ability to delay gratification may have something to do with how cuttlefish forage for food. The cuttlefish spend most of their time camouflaged, waiting for prey, says Schnell. They only move when they are feeding, but then they are vulnerable to predators. It is possible that delayed gratification may have evolved as a byproduct. Cuttlefish have learned to simply wait for better quality food, he adds.